Hello everyone. So today we are gonna do preprocessing in machine learning. We will try to cover standard scalar mostly. So preprocessing is the important stuff once you just do your train test split, and there's a couple of things. This is I think official documentation in Scikit-Learn GitHub. So we have different kind of scalars. You see, there's a robust scale. There's some normalized guys, min-max scale. Like they have different mathematical formulas, and we do have some encoders as well. But today we're not going to go with encoders. But the general idea is that encoders used for words, right? So you have yes, no's. You have like a couple of low, high, medium kind of columns that has these values. In that case, you use encoders. But for numerical ones, we better use scalars. And why we need scalars because different columns, different column names can have different units. And the age doesn't change too much. Age is like change between, let's say, maximally 100. But when it comes to the weight and height, it will be different. When it comes to the income of your, it will be way more different, right? So we don't want our model, our whatever uh, chosen model, don't confuse that the just because the other number, other columns values are a lot of times is bigger than the other one. Well, let's just give a lot of weight to this one. That's why scalings are important. And the most important, guys, is the most useful ones is just standard scalar. And the formula is here that you just subtract the mean and divide it by standard deviation, right? And it scales the features to zero mean and unit variance. That's the important stuff. So you can, I think where's that? Yeah, we can copy and paste it and see what's going on with this one. And this is the formula over here, and x minus u use I think the mean of the as the standard deviation. And anything else today? No, this is just the only thing. And no, we could have a lot more about this one. I say unit variance. I believe there should be. Yeah, that's it. That's not this one. Yeah, standard scalar. It performs the scaling to the unit variance. So we will just directly start. I think. Also, I would like to say that there's a robust scalar. It is robust, as the name says that, and it subtracts the median. And when it comes to the mean and median difference, median is more safe, much safer than the mean, because mean, is when you have some outliers. Median shows your data distribution as a descriptive better than the mean, right? And we have a quantile transformer, and it just maps your data to uniform or some normal distribution. You are using the quantile, right? And how about it is a data set distribution of some columns change in standard scalar and robust scalar? It doesn't change, but quantile transforms, since it performs nonlinear transformation, it forces the data into perfect sum normal shape, right? So we will have the data set from the previous video. It's just again the student performance data set that we're gonna go quickly. So let's import pandas as PD. All right. So let's just do assign df to pandas with CSV guy, and a pandas going to this CSV file, which is student performance. Right. That's CSV. Let's see what's going on. Yeah, we have error. I don't know what is this error. Oh, we don't have student performance, so I have probably some typo. Performance. Yeah, it should be fine. Yep. So let's see what is going on with the effect. We have some disk guys, and yeah, from the previous train test split guy, you already know that we are not going to use this student ID, and we're not going to use this final exam target value in the features, right? So let's just go with this one. We are going to need X and we're going to need Y. So df drop, I'm going to use the columns that I don't want to have in my features is student ID, and also and also final, where is that? Final exam. Yeah, there's gonna be a and for y, no, man. And for y, since it's supposed to be target variable, and I'm gonna do it with a lot of cycles. Oh my goodness! And final exam. I think that should be fine. Okay, let's run, and yeah, that's fine. So now let's do train test split. But before we do it, import from SK. Oh no, from SK-Learn. Model selection, import train test and split guy. Alright, so that's fine as well. So we are gonna see that a train test split guy. Take your x and y value and assume that random state is 42 or 32, and give me test size of 0.1. Train test split, and distribute that split in x train, x test, and y train, y test. Okay, I think it should be fine, even if it's not. Still, yeah, it's fine. So TF shape was 1015 features and 1000 rows, but in x train guy it is gonna be shape, yeah, it's gonna be 900. What about x test one? Not too man. X test one and shape, it has to be some 100, I think. I don't, yeah, it should be some, yeah, 113. The reason it's certain because we did eliminate drop 2 columns. All right, so yeah, now we can go ahead to the scaling stuff. Though again, StandardScaler should be added. So from Scikit-Learn again, it is a pre-processing stuff. I think you see this also did in the official documentation named that Preprocessing. Preprocessing, import StandardScaler. That is right, I think. StandardScaler import. Okay, let's import that. So I will just go ahead and name scalar equals some StandardScaler, and that's fine. I will later change this guy a little bit. So I think I'm just gonna change it now. So when you do, when you scalar train data and X train guy, and you will have scale version of them as numpy array. So we don't want it to happen because I do want to see when I do some dot head, this 2 parentheses, I want to see data frame, right? So Scikit-Learn has set output, transform the output into the pandas. So it's just better to do it right now rather than just waiting. I think that should be fine as well. Wonderful, right? So we added scalar and everything seems so far fine, I believe. All right, so just in case you're wondering, the StandardScaler needs to be applied to normal distributed data. So our numerical columns, let's just see what are those guys. So I'm gonna go with columns, right? So it's not helping too much, but I will copy, that's why I did that. And how about types of these guys? The types. Right. All right, so we need numerical guys, right? The float ones, integer guys, and for example, not this object one. And that's why I will just copy this one and I will assign them into some numerical columns that I will use numerical columns, let it be. And let me just clean it. So we don't integer or float starts with study per week. So I'm gonna delete all those guys. I don't need that. And I don't need this final exam definitely. It's target variable guy. And we don't need this rest of stuff. but I think there was internal access and extracurricular things, so they were probably yes/no questions. So that's why categorical variables, we don't need that. But attendance rate, absences, sleep hours, all of them are numerical columns. That is, I think, good. So now let's plot them. Let's plot their distribution. So I'm gonna do import matplot. Yeah, let's just go over here. And we don't need Seaborn in this case, I think. So I'm gonna go for column and numerical columns, right? Yeah, X-train guy, X-train, and this column plot. I want my plot kind to be kernel density estimation, KDE, and some color will be better to add. Let it be blue. I think, yeah, blue. And also the title should be F, for example, what KD for some guy, yeah, for column, and plt dot show. Okay, let me see if it works. Yeah, it does. It does. Yeah, we have a little bit. So yeah, it should be outside over here. Okay. So current density estimation guy for study per hours week seems normal, and kind of left squid and right squid kind of, but still seems normal. This is probably normal, and yeah, but our data set is pretty not too big, but it is big enough to apply standard scaler. You know, we can still go with robust scaler, but let's just use you know, I will choose standard scaler because it's not going to affect too much. So we don't have too much of discrete data set. So let me hide this guy. And I think we did add this scalar blah. Now it's time, take this scalar and scalar fit and transform this one, right? And into X-train guy. To which columns, and you can definitely write some sleep scores, blah blah, but we know that we have a lot of columns and we did assign them into this one, into this list, so I'm just adding here. And let it be, since it's train, let it be X-train scale, right? Scale it. And I will do the same thing to the test set, but be very careful with that. X test scaled. All right. Be very careful because you don't want to fit it. So data leakage ain't happening over here. And test. Okay, fit means learn. Okay, learn from data. So we don't want to learn from test data. Okay, that's so far. Yep. Let's go ahead. All right. So now if I do X-train, it will show me whatever we choose. If I do X-train num columns, yeah, it will show me this guys. But this is not scaled one, right? All right. To see the scaled one, we do X-train that scaled. Oops, it was I think underscore. Yeah, underscore. So we get this guy. Yeah, here we have it. Study per week. Study per week was over here with some big numbers, but it is now scaled, and all of these other guys as well. So, all right. So, how about like we need to prove, right? If we go to X-train dot, for example, number of columns again. Number of columns dot mean. Now let me just see what's happening. Yeah, we have some 13, some 87, and some 7 absences, blah blah. How about standard deviation for this guy? By the way, this is not scaled. This is just trained data set. It's not scaled. Okay, it's also different. And let me just duplicate this guy. Alrighty. And now let's do scaled one, right? So yeah, standard deviation is 1. And we can write round 3. Oh no, round, yeah, or maybe even 2. There, 1. I just got 1 for the sake of getting 1. So how about this scale, guys? Standard deviations, yeah, mean. How about this one? Yeah, it is 0. So we just scaled our numerical value successfully around the mean of 0 with a standard deviation of unit value, which is 1. Okay, thanks for watching the video, and I will be adding the other processing things like regarding to the encoding so soon. So thanks for watching again. See you.